So good afternoon, everyone. It's a really long week for some of us, those who are involved in teaching and research and doing all the fantastic work during the weekdays. And what a wonderful way to end this week is to learn about open manufacturing, open innovation and distributed manufacturing. It's a very short notice talk, and it happened that we came to know Vaibhav is coming from India. And we thought, like, why not utilize this particular opportunity to talk about and learn what exciting things happening in India at the same time, also learning from the theoretical perspective of or concept of open innovation and distributed manufacturing. So who is Vaibhav? How I met him? That's a very interesting thing. Just wanted to bring that perspective, that why we are here. During COVID, somehow an ex-Met student, Lucia Corsini, sent me an email that there is an organization in India trying to develop oxygen concentrator because there is oxygen shortages there in India and lots of people are dying. And they are trying to develop it, but they are struggling with the quality management and assurance topic. They needed some help. So she asked me to talk to Vaibhav and Richa. I was about to ignore that email, then I saw in CC there is a name called Professor Jaideep Prabhu written there. So like, oh, I can't ignore now. So let's send an email and let's have a chat. So that's how I end up to talking to Vaibhav, Richa Srivastava, Anul, if I remember right. They are fantastic people doing something great that even I can't imagine that people are doing in any other countries. Because if you look at oxygen concentrator making in UK, what we know is the big companies are involved, not individuals, some young engineer coming from a course training, but then trying to take this huge job of making such a complex machine. And also, it was also something that a concept that we were working, which we call it inclusive manufacturing, distributed manufacturing in 2016, with few top academics coming together and talking about how to make manufacturing more democratic, how to make manufacturing more personalized. And when I was talking to Vaibhav, I realized, oh my God, this is happening. I can see this concept that we were talking in 2016 is happening in front of my eyes. So without any further ado, I just bring Vaibhav. Vaibhav will introduce himself because he knows more about himself. I just know I just know a little bit, but he will tell you everything exciting about himself and then tell you the presentation. Thank you, Vaibhav.
Thank you so much. Take that from you.
Yep.
Perfect. Thank you so much, everyone, for coming, especially on this Friday night. It means a lot, especially for me coming all the way from India. It's a great opportunity to be here, especially at the university. So, and thank you, Professor Mukesh, for having me. And organizing this session really means a lot. So I'm just going to tell you a little story, a little pandemic story, but give you a little brief about where are we from and what are we doing back in India, and then we can take it from there. So this is the space that we run. It's called Makers Asylum. It's a makerspace based out of Goa, India now. It started about 10 years back out of a little garage that you can see over there on the top left, about 250 square feet, to create a space for people like myself and others to come and share tools. But what started happening is that a lot of people started coming to the space to learn as well. And we slowly set up everything from a wood shop to a metal shop to a digital fabrication lab to a 3D printing lab to electronics and virtual reality. And we started doing a lot more programs because people now were coming from other cities, other parts of the world, and really wanting to be a part of this sort of a space and learn about learning by making, I would call it. And this was growing very organically. We were initially in Mumbai, and then as we progressed, I'll tell you the story of how we got to Goa in the pandemic. But initially we started in Mumbai, and that's where we kept building this beautiful community. And then slowly these programs that I'm talking about started to get bigger, and a lot more people from different parts of the world started coming. Slowly, universities start recognizing it and started giving credits to the programs. We've also done programs now in Paris and Australia and different parts of the world. And then these universities also started sending us students back to India for like credit-based programs. So slowly, now our space, if you can imagine, because it had to host so many people, started growing in size as well. And of course, the rent also started growing, and everything started becoming bigger and bigger and bigger right before the pandemic. Just some photographs of like the programs that we've done. And then we also started this very beautiful program called Innovation School, which is pretty much our mainstay right now, which brings together young kids starting at the age of 13 years and above, teenagers, to start building their portfolios and building their maker profiles really earlier on. What they're doing in this program is learning about some really cool maker skills, STEM skills, and then after that also applying it by coming to Makers Asylum for residencies and actually physically learning about all the laser cutting, 3D printing, all the fun stuff, and building a project that matters to them. So really using the space and applying their creativity. Because just a personal story over there, I grew up in New Delhi back in the day and never really fit into school. And it wasn't really meant for me, I guess. I was kicked out of like multiple schools, thrown around here and there, moved 4 schools in the same city, but never really enjoyed school as much. But somehow I managed to get to college. And when I got to college, I discovered makerspaces because my college was in Boston. And over there were makerspaces, there were labs, and people were very open to allowing people to get in and experiment, just like what you have over here in Cambridge. Back in India, usually tools are locked up inside cabinets, and you really need approvals from multiple professors to be able to access them. It's quite old school. So for me, it was a big thing, being around tools, being around a community of people who would share knowledge and do things. So I wanted to create something like that for younger kids, and that's where this program came about. And then eventually, in India at least, the director of UNESCO is very, very close to us now. He's like a friend. So he loved the program, and he started co-certifying it with us to give it a little bit more leverage and a little bit more weight. Because as a small organization, it helps to get that added recognition for some of these younger students. And now, now we have over 200 students in this program from different parts of the country and world, actually, 3 countries now. And they've gotten into some great universities like Princeton and Yale and other awesome colleges, and the program has been growing because they've been doing some really good hard work over there. And slowly the family has been growing. The alumni base of Makers Asylum is now in 30 countries now, so it kept growing. And then came the story of the pandemic. So Makers Asylum started to get known as this innovation hub in Mumbai with all of this. And also, yeah, I'll mention this, there are over 30 startups that have come out of our space very organically. We didn't really mean for that to happen, but this was just a byproduct of the fact that it was just an open culture of making stuff that led to all of this, including this, which is a 6-axis robotic arm that came out of Makers Asylum, went to Y Combinator, and now is growing very widely in the industry and being acceptable in different parts of the world. They have a very cool model, and a bunch of others. Just some figures about like the kind of work that we've done in the past, but let me get to the fun part. Let's come to the pandemic. So 23rd of March in India, just like over here, we went into a complete lockdown and everything shut down. So now no transportation, all the local shops were closed, no material access, pretty much nothing. Mumbai, which is usually a really buzzing city, worse than London, has a population density of almost like 10 lakh people per cubic kilometer or something. And right over there, there was nobody all of a sudden. Like the streets were empty and everything. And it was a scary time for a space like ours with limited amount of budgets. We're not a funded organization. So we didn't know what to do. We were like, oh no, like all our programs started getting canceled. We had all these students coming from different countries, all of them canceled, nothing happening now. So the first instinct was that let's just stay at the space. Let's quarantine at the space instead of going back home. At least we'll be around the tools, we'll do something over here. If we shut down the space, then it's over. So that's what we did. So a bunch of us decided to quarantine at the space, just a few, 2-3 of us in the beginning. We said, at least we'll be around our tools, we can build stuff, we can do something, and not go back home. And what happened after that was really cool. One, we started hearing about a lot of news around the fact there was a lot of PPE shortage, and that happened over here as well, just like every other part of the world. So we started with a simple initiative to try and make our own face shields using laser cutting. So we started designing them, and then we put down a little target of ourselves. Actually, I put a target of 1,000. Richa changed it to 10,000, like my partner. And we had a little war about it in the night, I remember, because 10,000 was a crazy number if you think about it. 10,000 shields for a little makerspace sitting out in Mumbai without access to materials, without access to anything. Well, the entire city was shut down, was quite crazy, I thought. And but I do want to emphasize that the value of that number from 1,000 to 10,000 over here was very, very beautiful. I'm glad that she did that, because that really forced us to think a little bigger and a little outside of the box, I would say. Because 1,000 we were thinking inside the space, but 10,000 was so big at that time that we had to think about something else. What happened after that? Beautiful. Next day onwards, volunteers started popping in. And now, instead of 4 people, we had 20 people living at the space, constantly working day and night, just making face shields. It was like clockwork. I haven't seen anything like this. We had literally transformed the Makers Asylum into a factory, very similar to what happened in Cambridge, where they did exactly the same at the Makerspace. And Jonathan can maybe share his story about the Cambridge Makerspace as well. And this is what happened. So there were like people coming in, and these were people from very different backgrounds. Some of them were doctors, some of them were doctors who weren't working at that time. And we actually got a lot of student doctors who were not able to contribute to be able to be a part of this initiative. And we got filmmakers, photographers, chefs, everyone that had anything to do, they were reaching out to us, and we were bringing them in to volunteer. We went through over 21 design iterations of the face shield very quickly. And honestly, we were scared to go to the hospitals to test it. So we were going to the doctors' houses and the dean's houses at night, after midnight, when they would come back home tired. We would go to their houses, test the face shield, get some feedback from them, and then drive back. It was quite crazy, but it was quite fun. We managed to get through a lot of design iterations very quickly and get to a product that was simple and worked. What was really, really exciting about the product was that this one, initially we started with a paper prototype. I'll just talk about this because I think a lot of you guys are manufacturing guys. You might find this exciting. We started with a paper prototype. Best way to start. Get into wood. Very quickly we realized wood is a very, very bad material for an ICU setting. If you think about it, it's like completely porous. All the bacteria, all the other sort of viruses can get stuck into it, and it's really bad. So we said, okay, scrap that. We moved to acrylic. Obvious choice for a makerspace because enough acrylic around. But then we realized acrylic is brittle, heavy. On the head, it wasn't comfortable at all. It was breaking. But the doctors were actually really happy with this. So we made about few thousand of them, and we sent them to hospitals, and they were really excited about it. They were like, we want more. Can you give more? Within a day, we started getting orders from hospitals that we could not imagine, like orders of magnitudes of multiples of thousands, and we didn't know what to do. That's when we hit upon this very, very interesting material. It's a material that none of us would have thought that made sense before this. The material is called foam board or sunboard. If you think about it, that's a commonly available material used for marketing and available in every stationery store, available everywhere that you can imagine, because it's such a common material. They use it for marketing, they use it for making prototypes, everything. And it happens to be waterproof because it's used outdoors, and it's non-porous. So we showed it to the hospital, we showed it to the ethical committees, and they all said, perfect, can you make, they gave us some ridiculous numbers, like as many as you can. We were like, yes, we'll get to work. And we started work right away. Another issue, now we started making them over there at Makers Asylum, and we were trying to make as many as we could, but the supply chain was completely choked. And I think sitting over here, this is the perfect thing to talk about. The supply chain wasn't moving. The only way we could transport the face shields from Makers Asylum to the local hospital were either ambulances or police vans. So we literally had like a line of ambulances every day coming to Makers Asylum, and we were super scared of getting them inside Makers Asylum or inside the lab. So they were standing outside in lines. There were police personnel, doctors, everyone standing outside waiting for their order of face shields so they could take it and run away. Unreal. Yeah, that's another photograph of the foam board design that we started to make. Then what we did, which was really exciting, we'd already open sourced the design. I mean, since the beginning, because of the philosophy of Makers Asylum and the open source community of makerspaces, the first thing that we had done was we put all the files up on GitHub. But we went a step ahead. We started making videos. We started making videos on how to keep your lab safe. We made videos about how to start your assembly line, how you can create an assembly line so that you can actually copy this, not just the thing, but also start putting the dots together. We started connecting laser cutting shops because there are enough and more laser cutting shops across India, if you think about it, because it's a commonly used tool in marketing, once again. And we connected laser cutting shops to local maker communities and then to funding bodies and to the local hospitals, because they were all reaching out to us because the news was spreading through press and media and through social media. Like, it started to go a little viral. And what happened after that was something that we could have never imagined. 42 cities, towns, and villages joined us. Everyone from BBC News to all the Indian news channels were going crazy about this story. Every day we had more labs joining, more orders coming in, and more people wanting to be a part of this. And we went from 0 to 1 million face shields in 49 days. To just put that into perspective, it took us first 15 days to make it to the first 100,000 face shield. Then after that, it took us 7 days to make the next 100,000 face shields. And eventually, if you look over here, we were making about 100,000 face shields a day. That's another very interesting graph that was made by one of the community members who was tracking this like religiously, like what's going on over here. That's Makers Asylum. It was just a steady, beautiful line. We didn't do much, honestly. We were just like consistent. We kept making, we kept at it. That's all we did. But then you can see the other labs joining every day, different numbers. And what was beautiful was that some of these labs were making more shields faster than us. So now not only were we sharing knowledge, but we were learning from them on how to scale. So it wasn't a one-way street of knowledge exchange. It was a two-way street, which was very beautiful. There was a point which was, I think, one of the most beautiful points around the 500,000 or 400,000 mark, when Makers Asylum was making more shields through the M19 initiative than we were actually physically could make inside our lab, which was so beautiful that we were just like, that is the beauty of collective distributed manufacturing, where you can produce more without actually building or making yourself. In other words, Professor Jaideep's words, do better with less, I would call it. That's a fun memory of Professor Jaideep and Navi, who wrote that book. They wrote a beautiful chapter about our story much before the pandemic in their last book, Do Better with Less. And then they'd come home to meet my parents in New Delhi. So just wanted to share that as well now that we're here in Cambridge. So since then, I've always wanted to be here. And now, finally, first time, managed to make it. There's another little photograph of doctors, police personnel, everyone literally were wearing face shields by Makers Asylum at this point, at least in Mumbai. All the photographs started to coming in, and thank you messages, some very heartwarming messages started to pop in. The people behind this, completely interdisciplinary, like I said, musicians, artists, doctors, people from all different backgrounds, and that was the beauty of it. And there were over 300 volunteers in over 42 towns, cities, and villages that got together. And the way we were communicating were via Zoom calls and having celebratory videos at the end that really got the community together so that everyone could really be part of this initiative and feel one. Then, of course, the beautiful thing happened via Lucia Corsini. She wrote a really nice article about it at the University of Cambridge, and then OSMS captured it. They wrote a nice case study about it. So it started giving more legitimacy to this initiative in those early days, which was very nice. But still, we spoke to a lot of funding bodies. We spoke to a lot of grant bodies. We tried to explain them that, listen, guys, we're in the middle of a pandemic over here. We need to think different. Why are you funding only centralized manufacturing? You need to be able to fund localized manufacturing, a distributed manufacturing network, something where you can actually support local communities to be able to create locally rather than do the old school centralized manufacturing. How are you going to transport stuff? How many hands is it going to exchange? That's just completely does not work in this case. But sad, none of them listened. Nobody came on board. Then came wave number 2. In the middle of wave 1 and 2, we worked on a lot of devices. We managed to work with Ames Hospital and making some respirators. We made some superhero face shields for teenagers so that they could actually, using some behavioral design, so they could actually have some fun wearing some shields. We made baby shields, which went completely viral again. And even up till just last week, people had been ordering them because for newborn babies, there was no product out there. So we made face shields, which were really comfortable for them using foam and soft for them. We made sort of these little respirators for senior citizens so that they can get fresh air inside their mask. We tried a lot of stuff. And then comes the story of this guy. Second wave, I don't know if you heard about this over here, but in India, we suffered a grave time where there was a huge oxygen crisis. A lot of people lost their lives very quickly, and it was quite sad. We were completely not ready for it as a country, I would say. But as a maker community, however, the talks about oxygen crisis were going on since December, whereas the wave happened somewhere in April. And we were talking about the fact that India is not prepared for it. And whereas some people were also talking, and we talked to hospitals, none of the hospitals listened to us. They were like, what are you talking about oxygen? We have enough oxygen. And we were like, do you guys know about oxygen concentrators? But none of them knew about oxygen concentrators. All of this was happening. And then hit the second wave when everyone started going crazy and a lot of people died. Around that time, India was importing a lot of oxygen concentrators and people were donating oxygen concentrators. And this happens to India a lot. Whenever there's an issue, people donate stuff, like immediately, a lot of donations going in, and that was happening as well. But we went on another mission to try and create indigenous oxygen concentrators, try and build oxygen concentrators using locally available materials. We studied various open source designs that were available, like the Apollo design, the Marut design. There were multiple open source oxygen concentrators that were there, but none of them were really manufacturing ready. They weren't ready to be certified, they weren't certified, they weren't ready to take them out. So we started building our own. We started the R&D with the entire collective again. The same guys that worked on the face shields, plus more joined this time. This time we had over 600 people now as part of the M19 initiative in all parts of India and the world actually contributing towards developing oxygen concentrators in a very short amount of time. Zoom calls going every day, teams being formed, chats going crazy, and we went through iteration 1 to 2 to finally the M1902 within 4 weeks. The M1902 now is a certified oxygen concentrator, managed to get all the basic checks in order. It's not certified by medical authorities to put on a patient yet, but it passed all the other tests. The reason why we didn't get the test done for giving it to a patient, because that requires full ISO standards and requires certain other FDA approvals and blah, 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 that did not make sense for a makerspace like us. Though we could have gotten it, but we did not choose to get that because there was a lot of funding that would have gone into just getting that, and it wasn't required at this point. Because what we were trying to do with this project wasn't to be able to manufacture and sell oxygen concentrators. We were building them with the motivation of just one thing, to be able to share the knowledge with local manufacturers and local makers and other small companies, SMEs, large companies, so that they can also start making it locally versus importing them. The study of what happened during this time was very, very important for multiple reasons. One, there were a lot of issues for oxygen concentrators that came from outside of India. One, when they were being imported, they had issues like humidity. They weren't capable of being running at 95% humidity, which coastal belt of Goa has. They weren't ready for the kind of temperature that they were being put in. There were so many other issues that came up with it. But with this oxygen concentrator, we tried to deal with all of those things. We did a lot of research around dehumidification and using moisture separators like this one to remove the moisture before it enters the oxygen concentrator. We used localized parts, so it was easy to replace and work with again. What was beautiful after that? over 30 organizations were able to take our designs, create their own versions, even go into manufacturing, some of them, and get their own certifications. We did not get the certifications, but then they managed to get their certifications, which was great because that validates our design as well. And then finally, thanks to Cambridge University again and a few other amazing organizations that really understood the cause, and they started supporting this initiative, and that's why it was possible. They really helped in terms of giving us the funds to be able to make that happen. So these were some of those guys that made that possible. But while we were doing this, on the other hand, this is what was going on. Other companies were still importing oxygen concentrators now. And over 300,000 oxygen concentrators were imported within 2 weeks' time. Literally, aircrafts, big Boeings were chartered, only oxygen concentrators on every single seat, on every single cargo line, everywhere, only oxygen concentrators because people were panicking and people needed those. And what happened after that? A lot of them started breaking, as we can expect. We also managed to do a lot of studies to understand what went wrong with them, but so many of them broke physically. So many of them had those temperature and manufacturing failures. They had simple electronic failures sometimes, like a battery missing or cables not connected properly on the inside. People did not know how to use them. There were issues like voltage, some random issues, like simple issues. But the problem was nobody knew how to fix them. And once again, that's where we started hosting repair camps. We managed to get a little grant from the European Union, once again, and we used that funding to be able to set up repair camps all across India, to use that knowledge of the maker community that worked together on building them to actually start fixing them now, because that was the need. More than actually manufacturing them, the need of the hour was to be able to fix them. So we used our strengths and our energy, in that case, to start hosting some repair camps. We hosted repair camps in our space, in Pune, in other places, and then we also started doing repair camps eventually digitally to be able to share that knowledge with other labs, even in other countries like Ukraine, Italy, and others that were also facing similar issues and had issues with their oxygen supplies afterwards. Okay, the crux. I'm pretty much at the end of my conversation. The crux of all of this. If you think about it, the last 20 years of the global maker movement has fueled a different mindset if you think about it. People never thought that a community like the maker community of just citizens getting together, people who have other day jobs, students like us, can go ahead and be able to build something and manufacture at some scales. If you think about it, 1 million shields in 49 days wasn't possible for any industry. No big company was able to create that kind of numbers, but it was possible via the maker community. Not only that, if you look at the larger numbers, a bigger study done by OSMS, what was so beautiful was, this is a little story of India, but what was so beautiful was that the entire maker communities across the world thought in the same exact way, including Cambridge University, the Cambridge Makespace, which was so beautiful to hear the story, and so many other makerspaces across the world thought in the same exact way. The moment the pandemic hit, all the makers got to work. That's it. We didn't know what else to do. We didn't want to sit at home. So it was that time when everyone just got to work. And that's what happened. Within just that time of the first few months of the pandemic, this was some numbers that open source medical supplies put together, that how much actually did the maker community contribute. 48.3 million units of medical supplies, $271 million worth, within just the first few months when they were actually tracking this right then. 42,000 people were part of this initiative globally. So you can just imagine what was happening in other parts of the world. Africa, India, such stories started coming about, which is so beautiful. And for us as well, it was so humbling to see that it was the same thing that every other country and makerspace did. With that, that's my story. That's what I wanted to share with all of you. And we worked on one very important thing after that. I'll just like to conclude with that, and then I'll bring up Professor Mukesh, because then we can have the little conversation. When we were working on these face shields, we discovered there was a very, very important problem. The problem was that of quality checks and quality assurance. Because I'd like to acknowledge this, that while there were 42 cities, towns, and villages, working on face shields and using the same design, but they did not follow the same kind of checks and thoughts as maybe we did because we were working with doctors. But some other ones in smaller cities and people making them at homes or other places, they weren't following the same exact process and thoughts that possibly we did. And that is very, very important, because when it comes to a small device like a face shield, that could lead to failures in the hospital, but that wasn't a very critical device. But with something like an oxygen concentrator, that question was highlighted again. And that's where we started working with Professor Mukesh, Roman, and Professor Jaideep, and that's where the email popped into them to be able to answer this very, very interesting question, that how do we scale in a distributed, decentralized manner, but also making sure that we follow some quality assurance and guidelines, and that can be done in a way that we can really leverage this open community of makers going forward, and work with citizen-led innovation as well in an open manner, but at the same time do that in a way that it also adheres to all the quality standards that we talk about in the industry. So with that, thank you very much. Thank you for listening.
Thank you, Vaibhav, for such a moving presentation. We learned a lot what you did, and that's the thing that I was saying, that when I met Vaibhav, then I realized the scale of things that is happening. So two words are very important here that we wanted to actually know about it. It's about open innovation and distributed manufacturing. If we put in academic word, because we are in academic institution, and I am not the right person to talk about open innovation. I thought, like, let's take some help, and in front of Legicia, sorry if I explain open innovation in a little bit bad way. So I thought, like, let's take this funnel, and open innovation is lots of ideas you have at this side of the funnel, and then you have a target product coming out of this. But it's not open innovation. There are lots of holes, there should be more holes in this tunnel. Things should be coming out, many technology things come together, lots of ideas come together from different places, internally, externally, it's more collaboration. I think I'm using all the right words, right, Legicia? Oh, thank you. So this is the famous diagram you can see anywhere when people talk about innovation or open innovation or closed innovation. This funnel has to come. So that's why I thought, like, those who don't know about open innovation, we should know about this funnel. The second bit is distributed manufacturing. My God, this is the new heavy word, but it's very simple. Distributed manufacturing talks about we have new production technology and processes, and digitalization means digital technology. If we combine these two things together, we can achieve three objectives which was not achieved for a long time, which is called democratization of manufacturing. As you know, getting into manufacturing is a huge barrier. You need big money, big factories. The second one, and also many people can participate. The second one is personalization of product. So you can personalize for individual needs. And the third one is what? Localization. You can make it very near to the consumption. And that's why this whole talk that you see is actually fit into all those things. Lots of ideas coming from different places. You have looked at, if I just talk about makerspaces, I always thought that Tim always makes the Donald Trump or political figure pictures out of those 3D printers. It looks very nice as a product, but it looks like a toy. What he's doing? I never understood that one as a manufacturing. But then you can see, you can make a simple product such as face shield. Looks like a simple, but it's very complicated from materials point of view. Think about how many iterations they have gone through. But also try to think about the complex product, the oxygen concentrators. My God, how many parts were there, Roman? More than 60 parts that we were looking at. Then later on, it got 3 phases of evolution happened. So they are making now much more complex product. How they are doing it? Why Vaibhav has to do it? Who would the makerspace? Who has given them right to do it? Anyway, we were looking at more democratization of manufacturing. So that's how it fits into those pictures. So for me, a question comes to Vaibhav is, when you started doing it, quality issues, when it came to your understanding, why that was so important for you?
So I remember one thing. One of the hospitals sent us a video, and they showed one of our facials breaking and popping out but flying out, like literally in the middle of the hospital, which was like, when we saw that happen, we were like, wow, that's quite scary. I hope this video doesn't go anywhere. But I also was like, I need to save this video. This is very, very important. This is exactly the question that we've been trying to answer. That we're just a bunch of kids over here, or whatever you want to call us, who are trying to now manufacture a very, very important medical device, and something that is an important PPE equipment for hospitals. And hospitals were using this. They were using it in the ICUs, they were using it everywhere, and they were banking upon us, and they were reaching out to us for more. So we had certain, I would say, responsibility over there, just from our personal side, which was that now that our product is going out into the hands of the user, and especially the hospitals, we need to make it right. And another thing that I would point out, that if you saw over there in the photographs, every single person in the photographs was wearing the face shield and the mask while they were working on the face shields. If you saw that, I don't know if you noticed that. One of the reasons why doing that is, yes, of course, we were shit scared, because it was a very, very scary time, and we were in a room full of people. But the other very important thing, we were user testing constantly. We were trying to be the user. We were trying to, because we understood from the hospitals that they need to wear it for 8 hours a day, and it's giving them pain points on their sides, all the issues that they were giving us. So the reason why we were wearing them exactly the same, pretty much all our shifts, we were wearing the face shields in the same exact way before sending them out, to be able to know what exactly is our product doing, where is it going bad, what is the part which is uncomfortable, can we fix it? So we knew all the issues before they actually happened, and we got the feedback eventually when we were able to catch up, when we had that time, and the rhythm was picking up. But yeah, that was, I think.
No, that's a very good example. And then you can think about this, what if happened to the face shield, what will happen to this oxygen concentrator? If we don't maintain the quality. Quality is not just looking at the design part of it, manufacturing processes part of it, and also looking when it's running also, right? Or what Roman found out very nicely, I thought we solved the quality issues a long time ago in manufacturing. But I think Roman told me, no, Mukesh, it's not true. Yes, we have solved some of these problems, but still lots of recalls are happening anyway without COVID. And this is an important issue that we should actually look at it. And we are looking from digital technology perspective, how to bring digital certification in this area, and also bring the digital auditing for quality, which is very interesting topic for Maker Asylum. One of the things that these small pockets of manufacturing that is happening, which very impressive skills, our quality management system, auditing, and standard bodies have failed them not to develop any particular kind of processes that can support these kind of activities. And we are going to work with them in order to develop that particular knowledge, practices, and tools. So that's one part of it. What you can talk about this open innovation, how different people came from? Because if I learn, you had people sitting down in America, you had people sitting down in Cambridge, you had people sitting down in Saudi Arabia or in Middle East, and different parts of India.
Right.
What kind of challenges, how digital technology help in open innovation? Can you just talk about that?
No, I think we live in a beautiful time, and this is only possible now, if you think about it, where everything is so connected around the world, and people are able to contribute no matter where they are. And that's the true advantage of digital and localized, and at the same time, where you're able to create hardware like you could never before as well. If you think about it, hardware manufacturing was only thought about, or prototyping as well, was only thought about as a thing that would have inside a lab, one specific lab, everyone needed to be there. But now what was happening over here is that, like Professor Mukesh mentioned, there were people in different parts of the world now contributing to the design. Somebody was working on the PCB in Saudi Arabia, somebody was working on different parts of the concentrator when it comes to the sieve beds in Switzerland, somebody was helping us out with different parts in India, and we were able to put all of those things together and be able to create our own little, and recreate that stuff in India, I would say, by learning from them. While they were able to share digital files with us, we were able to use digital fabrication tools like 3D printers, laser cutters, PCB milling machines to be able to really quickly prototype the same stuff there and to be able to create that there. And that's possible today. I mean, what's happening over here as well inside the university, there's so many 3D printers, so many digital fabrication tools. The way we exchange knowledge has changed quite a bit.
Yeah.
So